Okay guys, this is the review for 4A test that will happen on Friday. On question number 1, we're going to start looking at writing a system of equations from a table. The table of ordered pairs represents here lines Q and V. So let's write the system of equations that represents this. First, we're going to take a look at table 1, and then we'll take a look at table 2. So number 1, we're going to have to find the slope. So for table 1, what is the slope? And I notice one thing, that I have a y-intercept here because it's going to be 0, -2. So if I do that, then I choose another point. This is P1 and this is P2. So I will do 0 minus -2 over 1 minus 0. Okay, so this is my x column. You can tell this is my x, this is my y, so the m is equal to y2 minus y1 divided by x2 minus x1. So this gives me 2 over 1, and therefore my slope is 2. Since I circled P1 earlier, right here, and this is my y-intercept, I know that P1 is my y-intercept point. So if I write it in the equation y equals mx plus b, then y equals to 2, because that's what I have here, x minus 2. And that is my equation. Okay, so P1 here, I'm going to go ahead and remember again that I'm going to use this as my y-intercept. So this comes down over here. And then this 2 comes down here. Okay, that's what I have there for table 1. So to continue on, I'm going to look at table 2. Table 2, notice I do not have any y-intercept points because I do not have any x value that are 0. So I'm going to have to solve this kind of like the long way. I'm going to go ahead and choose 7, 2 as P1 and 5, 3 as P2. So for table 2, I'm going to use the slope. And I'm going to look at subtracting my y values, 3 minus 2. Divided by 5 minus 7. Yeah, 5 minus 7. So what does this give me? 1 divided by -2. So that's my slope right there, -1/2. Then I have to go ahead and plug this into the the slope point slope form. So the point slope form is y minus y1 equal to m times x minus x1. So what is my x1 and y1? Well, I'm going to go ahead and circle this guy right here in blue now instead of red. And I'll choose this point to be my x1 and y1. So y minus 2 equals to my slope, which is -1/2 x minus 7. Okay? So now, like we did before, we're going to go ahead and distribute this -1/2 into here to the x and -1/2 to the -7. So y minus 2 is going to equal to, I'm going to go ahead and erase these arrows real quick so I have some room, -1/2 x minus, but remember now this is going to turn into a plus because a negative times that negative becomes positive, and I'm going to have 7 times 1 is 7, and then divide that by 2. And then the next thing I need to do here is add the 2 to both sides. So right here, I'm going to go ahead and add 2 to both sides. And you're going to notice I'm not going to be able to add this 2 to a fraction just yet because it's in a whole number form. So negative 1/2 x plus 7/2 plus 2. So the next step I have to do is I have to change everything here so I can turn into a fraction. So number 2 has to turn into a fraction. So that will become 4/2. And so I'm going to continue over here. This will read y is equal to negative 1/2 x plus 11/2. So that's my second equation. So that is my system of equations written in slope-intercept form. Okay? On the second problem, now we're going to look at finding the graphs of lines F and G and write the system in, one will be in standard and one will be in slope-intercept. So the first one, let's look at F. How do we find the slope? So number 1, we're going to find the slope. Now you notice F, I can start at a perfect point. I can start like over here, or I can start here, or I can start right there and then up here. So let me start right over here. So notice that this point is going to be 0, 3. That's an x, that's a y-intercept. And the next point over here is going to be 2, 2. So how to find my slope? I can graphically look at it as I go down 1 over 2. So my slope is negative 1/2. Right? I go down 1 over 2. The second part is, since I have a y-intercept, I can identify that as b equal to 3. Right? So since that equals to 3, then my third part is, what is it in slope-intercept form? So I just fill in the blanks. So y equals to negative 1/2 x plus 3. So that's my first equation. Okay, so now that we have our equation for F, let's look for G. I made it blue so that we can discern it from the other graph. First step we're going to take a look at again is, where does it cross the y-axis if it does? What happens across the y-axis over here? That's perfect. So that point is 0, negative 4. Now, the next point we have to take a look at is, where does it hit in between the grid lines perfectly? It seems to hit the grid lines right here. So that point is 1, negative 1. So if I look at this, the slope goes up by 3 and over by 1. So my slope is 3 over 1, which is 3. So the second part to writing my equation is, I know what the y-intercept is. My y-intercept is equal to b, which equals to negative 4. That was the first point that I found right here. So I'm looking at this negative 4, the y-intercept. So in part 3, I'm going to go ahead and write it in slope-intercept form. Y equals mx plus b. So then y equals to 3x minus 4. Then I'm going to go ahead and write it in standard form. So standard form means I take all my x's and my y's and put them over to one side of the equation. So in this case, I'm going to move the 3x over to the other side by subtracting 3x, so it would be y minus 3x equals negative 4. And then I'm going to rearrange it by writing it like this. Negative 3x plus y equals to negative 4. And I have one more thing I need to do. I cannot have a negative x coefficient. So I'm just going to flip the signs, and I'm going to make it 3x minus y equal to positive 4. That's all I did. I flipped the signs of everything else. So this is the fifth step, and this is my second equation for g. This is for g. So I now have a system of equations, and my equations is written like this. 3x minus y equals to 4 is the g line, and then the f of x line is negative 1/2 x plus 3. That's y equals to, y equals to. And that's my f of x line. I wrote it as y equals to because that's what you're probably going to see it on the test like that, okay? But f of x is actually y right here. Okay, we can call it that. So that's my system right here. Okay, question number 3. A concession stand at a baseball game sells hot dogs and boxes of popcorn. Justin buys a total of 10 snacks. The number of popcorn boxes he buys is 5 less than twice as many hot dogs. Write the system of equations models this equation if he bought H hot dogs and P boxes of popcorn. Okay, so he buys a total of 10 snacks, and they're made up of what? Hot dogs and boxes of popcorn. So we're going to call hot dogs H. We're going to call popcorn P. So if he bought a total of 10 snacks, then obviously we're going to do H plus P equals to 10. We just don't know how many of each that he bought. The next statement that he told us is that the number of popcorn boxes he buys is 5 less than twice as many hot dogs. So popcorn is going to equal to 5 less. So what does that mean by 5 less? It means I'm going to subtract it from the total number of hot dogs. In this case, he bought twice as many hot dogs, 2h minus 5. And that's my equation. All I have to do is just write the system. In this next equation, in number 4, or next problem I should say, Dominica has a total of 17 coins in her pocket. All of them nickels and dimes. We've done this problem before. So here it is. Hey, great. They just gave it to us as 17 equals to n plus d. The value of the coins is 110 equals to 0.05n plus 0.10d. Using the following equations to represent the situation, how many nickels does Dominica have? So first, we're going to have to make a substitution here. Since they're both written in a standard form where all the variables are on one side, we have to solve for one of them. So I'm going to call this one equation 1 and equation 2. So step A is what we're going to do is we're going to go ahead and solve for D for equation 1. So equation 1, solve for D. So that means I'm going to move n to the other side. So I read 17 minus n instead equal to D. Because what I did was I subtracted this n to this side. Then in part B, I'm going to substitute. I'm going to sub equation 1 into equation 2 for D. So this equation right here, this new equation 1 right here, will go into D right over here. So this is what it's going to look like. Sorry, whoops. And that's what I have. So now, do you notice here that I have all my variables now down to one variable, n and n. So the next step I'm going to do is distribute. So 110 equals to 0.05n plus 17 times 0.10 gives me $1.70 minus 0.10n. And then I'm going to combine like terms. So I'm going to write up here, distribute and combine like terms, since I don't have much space. So you notice here, I can combine 0.5n to minus 0.10n. So what does that give me? That's going to give me negative 0.05n. And then this plus $1.70 is going to go over here and be subtracted from 110. So $1.10. So $1.10 minus $1.70 gives me negative 0.60. So if I solve for this, n is going to equal to negative 0.60 divided by negative 0.05. So what does that give me? It gives me 12. There are 12 nickels that Dominica has. So if there are 12 nickels, I can take that value for 12 and plug it all the way into here and solve for the number of dimes. If you solve for that, the quantity of dimes she has will be 5, right? Because 12 plus 5 gives me 17, okay? Okay, a bag contains 27 coins consisting of only dimes and quarters. First equation I can read off right away. Dimes and quarters must equal to 27 coins. So, D plus Q equals 27. That means the number of dimes plus the number of quarters must equal to a total number of 27 coins in the bag. The total amount of money costs $5.10, so that's a little bit different now. So I'd still take the same principle of D plus Q, but this time I have to go ahead and write coefficients. That's going to be their dollar value. So a dime is $0.10, a quarter is $0.25. So now I need to find out how many dimes are in the bag. So again, if I look at this, this is equation 1 and this is equation 2. Okay? So step A, we're going to take equation 1, D plus Q equal to 27, and let's go ahead and solve for Q. So in this case, we're going to subtract the D to the other side, and I'll get 27 minus D. That's for equation 1. That's my new equation 1. Then in part B, I'm going to put it into equation 2. So 0.10D plus 0.25. It used to be a Q after that. Now what I write instead? 27 minus D, and that equals to 510. Again, I'm doing a substitution rule, and I'm writing it here for Q. Then in part C, I'm going to distribute and combine like terms. So 0.10D plus 27 times 0.25. Boy, I got to go check that out real quick. Give me a moment. That's going to give me 675 minus 0.25D, and that equals to 510. Sorry, I kind of wrote that kind of weird above here. That's a 10 right there. And now I'm going to combine like terms. So I notice again that I can combine 0.10D to negative 25D. So what does that give me? Negative 0.15D. Then I'm going to take this plus 675 and I'm going to subtract it from 510. So then this gives me negative $1.65, I believe. Now to get D by itself, what do I have to do? I have to divide negative 165 divided by negative 0.15. So this will give me the number of dimes. And the number of dimes is 11. Okay, number 6. Alice likes to go to Main Event to play laser tag and climb the rock wall each Saturday. Instead of purchasing the play pass, Alice pays for each activity separately. This week, Alice played laser tag 3 times and climbed the rock wall once, spending $13. So first equation is going to be 3L plus R equals to 13. Second equation, last week Alice played laser tag twice and climbed the rock wall twice, spending $18. So 2L plus 2R equals to 18. So using the information provided, how much does Main Event charge in dollars to climb the rock wall? Okay, so we have a little situation here. We're going to go ahead and solve for L. So here we'll solve for L, so that way we can end up with R as our remaining variable, so we can solve for it. So if I look at equation 2, do you notice that in equation 2, I'm going to circle it. Do you notice that all the coefficients 2, 2, and 18 are divisible by 2? So first part, what I'm going to do is take a look at that and see, can I always reduce my coefficients and make it smaller? I sure can. So this will be L plus R equals to 9, and that is equation 2 now. Okay? So I divided everything by 2. So 2 divided by 2 is going to give me a 1 right here. 2 divided by 2 is a 1. 18 divided by 2 is 9. So in part B, I'm going to go ahead and solve for L. So L is going to equal to 9 minus R, and this will be my new equation for number 2. So in part C, I'm going to go ahead and substitute in part B into equation 1. Okay, so this will look like 3 times 9 minus R plus R equal to 13. So then part D, I'm going to go ahead and distribute and combine like terms. So I'll have 27 minus 3R plus R equal to 13. Then I'm going to combine like terms. So do you notice I can combine these two terms together? So this will give me minus 2R equal to, then I can take this 27, since this was 27 minus 3R, I'm going to subtract it from 13 right here. So 13 minus 27 is negative 14. So if I divide each side by negative 2, there's a negative 2 right? If I divide each side by negative 2, I'm going to write it up here. I'm really sorry. In part E, if I solve this, R is equal to negative 14 divided by negative 7. Sorry, negative 2. That gives me positive 7. So the rock wall climbing price is $7. What is the y value of the solution to this system of equations? So they already give this to you nicely as x equals to 2y minus 4. So take that and substitute that into the second equation at the bottom. So this is equation 2, this is equation 1. So what is it going to look like? It's going to look like 7 times, instead of x, it's going to look like 7 times 2y minus 4 plus 5y equals negative 66. So part B, we're going to distribute and combine like terms. So this is 14y minus 28 plus 5y equals to negative 66. Then we're going to combine like terms. These two terms I can combine together, so I get 19y. This term, negative 28, will combine with negative 66. But to do that, I have to add it over here. So if I add 28 to this side, I'm going to get 38. So then y equals to 2 when I divide by 19. So y equals to 2. Okay guys, special case system here. What is the solution to the following systems of equations? What I want you guys to take a look at is this. When you see this system, one of your answers is going to say infinite solutions. How do you know it's going to be infinite solutions? I told you guys before, it has to be the same number equal to the same number. Well, another way of looking at this is that if I compare the two equations, if you notice in equation 1 looks like equation 2, okay, or actually vice versa, equation 2 will look like equation 1. Big question mark. How? If I were to multiply this whole equation by 3, then the first equation remains the same, 3x plus 6y equal to 0, and the second equation will become 3x plus 6y equal to 0. Do you notice how these two look exactly the same now? Okay, I multiply the bottom, by 3, and look, they look exactly the same. So if I have the same equation, infinite solutions. This is a very helpful hint. Take a look at your equations and see if one equation can be written the same way as the other by multiplying it by a certain factor. I'm going to go ahead and do number 8 on this side. Check this one out. Now this one may not look so simple, but if I multiply the bottom equation by a negative 3, then the top equation stays the same because I didn't do anything to that. But the bottom equation becomes negative 3x plus 12y equal to equal to positive 9. Look, these two guys match up. They are the same. Since they are the same equation, since I multiplied the bottom equation by negative 3, since it's the same equation, I can get the same thing as the first one. I have infinite solutions. You will see this on the test. When you see that one of the answer solutions says infinite as a selection, take a look carefully at the equations and see if I can multiply either the first equation by number or the second equation by number to make them look like they're the same equation. Okay?